Okay, if you can please open up your textbook to page 455. It looks like Inquiry Lab, sorry, and it's solving equations with rational coefficients. And I just want to review, what does the word rational mean? The root word of rational is ratio. So rational is any number that can be written in the form of A over B. So in other words, a rational number is a fraction. So today we're going to work with solving equations that have rational coefficients. So a rational coefficient might look like this. 2/3 x equals 9. Notice the coefficient is the number that's being multiplied by the variable, and we're looking at situations where that number is a rational number, is a fraction. Okay, so we're going to start out here. How can we use bar diagrams to solve equations with rational coefficients? So here's our problem. 2/3 of Chen's homeroom class plan to participate in the school talent show. If 16 students from the class plan to participate, how many students are in the homeroom class? So with these questions, we want to focus on what we know. Well, we know the fraction that are going to participate, and we know the number of students in the talent show. So we know that there's 16 in the talent show, and we know that that is 2/3 of the class. What do we need to find? We need to find the total kids in the class. Okay. So if we think about this with a bar diagram, we need to know the total. So this entire bar is going to be our total. That's what we want to find out. And we know that 2/3 of them are in the show. So if you can see that out of this total, we divide it into thirds, and we're interested in 2 out of those 3. And 2/3 of the class is the kids that are in the show, and we know that that is 16. So using this equation, we need to figure out where our variable is going to be. So we're going to let C representing the total number of kids in the class. So this whole thing up here is going to be C. So to write our equation, we're going to take 2/3 times the total, and that equals 16. So when we take 2/3 of the total, of means multiply, we get 16. So then to solve this, we are going to use an idea of rational coefficients. Well, actually we can probably use a little bit more reasoning. We've done this before. If these two boxes are 16, doesn't this make each of these 8? So there are 3 parts that are all of 8. So that means the answer is 24 kids in the class. So as you can see down here, it fills it in. Since each section represents 8, 8 times 3 is 24. Okay, turn the page please. And we've got this scenario. Eliana is spending 3/5 of her monthly allowance on a costume for the talent show. She plans to spend $24. Draw a bar diagram to represent the situation. Then write and solve an equation to find the amount of Elena's monthly allowance. So I'd like you to pause this for a minute and make the drawing and see if you can set up the equation. When you're finished with solving it, then you can start this again. Okay, so if we look at the solution, we know that the total allowance is this whole bar, and we're dividing it into fifths. 3 of those 5 parts is $24. Okay, so if 3 of those parts is 24, that makes each of these 8. So we can easily see that her total allowance is 8 times 5, which is 40. If our unknown, or our variable, the entire allowance is A, notice the equation is we're taking 3/5 times A to equal 24. Okay, can you go down here please to number 2, make a conjecture. Suppose Eliana planned on spending 3/4 of her monthly allowance on a costume. How would the diagram and the equation be different? So please take a minute. I'm not going to show you that solution. Please take a minute to make an equation and a bar diagram and a description. Pause the video while you do that, and then restart when you're ready. Okay, so we're going to jump right into today's lesson, the real world link. Social network. 3/4 of the students in Alia's class belong to a social network. There are 15 students in her class that belong to the social network. So the thing that we don't know is how many kids are in the whole class, but we know that 3/4 of them is represented here. So we know that 3/4 of them makes up 15. Okay, so to finish this up, if 3 bars is 15, that means all of these are 5. So the total kids in the class would be 20. So if you look down here, based on this diagram, which of these equations would make sense? Okay, so I see the 3/4 and the 15 here, but are we multiplying 15 by something to get 3/4? This 0.75, where in the world did that come from? Oh, I remember that 0.75 is really 3/4. So are we taking 3/4 of the class to equal 15? So which of these do you think it is? Okay, just like before, we're taking 3/4 of the class, of means multiply, to get this. Okay, if you turn the page, I started with a lot of problems like this in many of the classes the other day. And notice that today we're going to do the same methods we did the other day, but this time our coefficients are going to be fractions or ending decimals that can be written as a fraction. So in a problem like this, we find our variable m. m is being multiplied by 0.8. So we do the opposite or the inverse operation of multiplying, which in this case is dividing. So we're going to divide both sides by 0.8 to be fair. 0.8 divided by 0.8 is 1, and we get our solution of m equals, and I don't have a calculator in front of me, I should be able to do that in my head, but it should be m equals 8. Okay, so can you pause the video please and show your work and do B and C, and I will check that when I'm back. Okay, let's go to Got It question D at the bottom. It says, suppose the ice cream cones cost $2.80 each. How many ice cream cones could the coach buy with $42? Okay, so if it's $2.80 each, we're going to multiply that by however many cones he decides to buy, and we're going to spend $42. So $2.80 times n equals 42. Then to solve this, we're going to divide both sides by $2.80. This comes out to be 15 cones. Okay. All right, so I think we're pretty good with dividing when it's a decimal. But what happens on the next page when we need to get rid of this fractional part? So recall that two numbers with a product of 1 are multiplicative inverses. Okay, we haven't talked about this too much, so can you underline the word multiplicative inverse, or they're also called reciprocals? So over here we're going to write some examples. We're going to come up with some fractions that multiply whose product is 1. I don't know why this isn't focusing. There we go. So a real easy one, if we do 2/3 and if we multiply it by 3/2. When you multiply this, you should see that the 3's will cross reduce to 1, the 2's will cross reduce to 1, and we get a product or an answer of 1. So 2/3 and 3/2 are called reciprocals or multiplicative inverses. So what would the multiplicative inverse be of 1/5? What would you multiply it by to get a product of 1? Well, you just flip it. Okay? We're going to use this concept to solve. So if you look at example 3, example 3 says 3/4 x equals 12/20. So to get x by itself, we want to get rid of multiplying by 3/4. And in other words, we want to think of something that we can multiply by that will make this become a 1. Well, we just learned up here that if we multiply by the reciprocal on both sides, because we have to be fair, what we multiply on one side we have to multiply on the other. Notice that these will all cross cancel. We're left with x equals, and now we have two fractions to multiply. Okay, so I'm going to cross reduce. 4 divided by 4 is 1, 20 divided by 4 is 5. 3 and 12 can cross cancel. 3 divided by 3 is 1, 12 divided by 3 is 4. And we get an answer of 4/5. Okay, your book shows a really good example of that if you get confused. Look down at example 4. They do the same thing, but this time the fraction's negative. So notice when you flip the fraction that's negative, it still stays negative, it's just that the numerator and the denominator flip-flop. So notice that the reciprocal of 7/9 is -9/7, and we multiply it on both sides. Our book does a really nice job of showing this cross cancellation, and notice we're left with -1 times -1. Negative times a negative is a positive. And then we multiply here. -9/7 times 5 becomes -45/7. Okay. Please go to the bottom here and take a minute to pause the video and do E, F, and G. When you've shown your work and you've finished that, then hit play again. Okay, so for this one, the reciprocal of 1/2 is 2/1, so you should have multiplied both sides by 2. These will cancel, and we get x equals 16. So check your work. And the next one, the reciprocal of -3/4 is -4/3. So we're going to multiply on both sides by -4/3. These all reduce or cancel to 1, and we get x equals, remember this 9 is really 9/1, so you multiply and get -36/3, which is -12. Okay, and for G, you should multiply both sides by the reciprocal of -7/8, so that's -8/7. And -8/7. These are all going to cancel, and we get x equals, notice 21 and 7 can cross reduce to 1 and 3. And 8 and 64 can cross reduce to 1 and 8. We've got a negative times a negative, so those are going to cancel, and we're left with 3 on the top and 8 times 1, 8 on the bottom. Okay, feel free to go back and re-watch this video if there's parts that didn't make sense. But you're going to turn to page 461 and you're going to do the selected assignment that is in your assignment guide. So this is lesson 6.3 and the problems are listed in your assignment guide, which are right here. You're going to do 1 through 10, 13 is accelerated, 17 through 20, 21, 22, 23, and 24. If you finish early, those that are doing acceleration, feel free to go to pre-algebra extension and to work on the videos there. Thanks. Have a good day and behave.